Okay, so this is the really hard one we did. I just want to go through this to show you the basic thing again. Okay, so most important thing in this whole description is that this is a regular hexagon. Remember what regular means? It means same, all the angles are the same, all the lengths are the same. And it has a side length of x. So that means that this is x, and 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 that's x. Right? Okay. And then the hexagon's enlarged by a scale factor of p. Okay, so that means that if that side is x, this side length is p times x, p times x, p times x, p times x. And we want to show the area of the shaded region is equal to this. Right. So to find the shaded region, what we need to do is we need to make a big hexagon, and we need to subtract a small hexagon. And that is going to equal the shaded area. Okay, so let's work out the small one because we know what the side lengths are, because it's got a side length of x. Okay, so our small hexagon, to work out the area, it's not a formula, but what we can do is we can split this into equilateral triangles. And the reason we know that they're equilateral is I know that all the angles around a single point in the middle add up to 360 degrees. And I've got 6 triangles. 360 divided by 6 is 60 degrees. So that means that each triangle is equal to 60. That's x, my side length. So if that's 60, these two must be 60. Okay, for all the angles to be the same, which means that this is equilateral. Now I can work out the area of this because I've got 2 side lengths and an angle between them. So I can use 1/2 AB sine C. In this case, it's going to be 1/2 x times x times sine of 60. So you put that into your calculator, you'll find that sine 60 is the square root of 3 over 2. That's what I've got over here that I've got to prove. Right, so x times x, that's x squared. So I've got 1/2 times x squared times the square root of 3 over 2. That's my triangle. Okay, so that's the area of my triangle. Okay, now I want the whole hexagon. The whole hexagon, there are 6 triangles, so 6 times 1/2 times x squared times the square root of 3 over 2. Let's simplify it. Well, 6 times 1/2 is 3. So I've got 3 times the root 3 over 2 times x squared. Okay? It's written in a slightly different order, but it's the same thing, right? So 6 times 1/2 is 3. There's my 3. X squared is still here. Square root of 3 over 2, that's still there. Now this 3 square root 3 over 2 matches, and the x squared matches with what I want. So that's my small rectangle. Now let's do the big rectangle. So the big rectangle, remember the rule that if I have a 2 by 2 square, area is 4. Okay, if I enlarge it by a scale factor of 3, my sides all get 3 times longer. So it's going to be 6 and 6. The area will be equal to 4, the original, times the scale factor squared. 6 times 6, we know the area is 36. So let's check it. 4 times the scale factor 3, 3 squared, means 4 times 9, and that is 36. So for our hexagon, the scale factor, and this is just our example, let's close that off. Okay, so our scale factor for the hexagon is p. So the area of the big hexagon is the original one times p squared. So p squared times 3 root 3 over 2 times x squared. Excellent. Right, so now all I'm going to do is do what we said at the beginning. I'm going to take away the small one from the big one. So I'll have p squared times 3 root 3 over 2 times x squared minus 3 root 3 over 2 x squared. Almost there. Okay, because now I can factorize this because 3 root 3 over 2 times x squared is a common factor. So I'm going to take that out and write 3 root 3 over 2. Put the x squared on this side only because basically that's where it is on the original. So now inside, what have I got? Well, it's multiplying p squared. And so I'm taking away one lot of that. If you look at this, 3 root 3 over 2. Yep. P squared minus 1. Yep. X squared. And that means that we have shown that that is correct.